Hey everyone, welcome back. You've officially made it to the 7th rung of our LogicLadder Explainer series, and man, today is a massive leap forward. Up to this point, we've basically been juggling single pieces of information, right? One name, one score, just one tiny piece of data at a time. But let's be real, real-world applications don't work like that. They handle massive amounts of data. So today, we're transitioning into managing groups of data using arrays and data collections, or, well, what I like to call the organized bookshelf. This is literally the final, absolutely crucial foundation you need before we launch into the big leagues, data structures and algorithms. Let's get into it.
Okay, I want you to cast your mind back to rung 3 of our ladder. Remember that single username variable we created? It was perfect, right? It held one user's name flawlessly. But here's a question for you. What happens when your app suddenly explodes in popularity and you've got 10,000 users? Just think about that for a second. You absolutely cannot sit there and create 10,000 separate variables by hand. No way. It would take forever, your code would be an absolute nightmare to read, and maintaining it? Totally impossible.
So to navigate this massive scaling problem, we've got a little magic tool called arrays. Here's our survival map for today's explainer. We'll hit the variable scaling problem, talk about the organized bookshelf analogy, climb the zero-index ladder, live code a playlist, and finally, look at the out-of-bounds trap.
All right, moving right into part 1, the variable scaling problem, and why one single variable is simply no longer enough.
When beginners try to build bigger apps, they usually hit this critical breaking point. On one hand, you have a single beautifully clean variable, username 1 equals Alice. Simple, right? But look at what happens if you try to scale that exact same approach. You end up with this chaotic, impossible list of thousands of manual variables. Username 2, username 3, going all the way down to 10,000. Just looking at it causes instant cognitive overload. Software simply can't function this way. Professional developers use arrays so they can store all those multiple items under one single highly organized name. And that brings us to part 2, the organized bookshelf analogy, where we'll be visualizing how this actually looks in memory.
To really wrap our heads around how arrays work inside abstract computer memory, we need to connect it to something real. Think about a standard digital grocery list. Milk, eggs, bread, apples, coffee. When you head to the store, you're not carrying 5 tiny, separate pieces of paper, right? That'd be crazy. You have one list with 5 specific lines. Well, in computer memory, an array acts exactly like this list. It's an organized bookshelf where every single item has its own dedicated slot, kept neatly together under one single reference.
Okay, on to part 3, the zero-index ladder, and adopting that true developer mindset.
Knowing our data is neatly on a shelf is awesome, but how do we tell the computer exactly which book to pull down? Well, we have to understand how computers count, because it's actually pretty different from how we count. Notice this direct comparison. Humans naturally count starting at 1, item 2, item 3. But computers start counting at 0, index 1, index 2. I'm actually going to use Turing shot here, just hitting Control-X, to draw a bright conceptual box right around index 0, 1, and 2. You see that? That is your zero-index ladder. The absolute first item in your array is always at index 0. Seriously, forgetting this rule leads to the infamous off-by-1 error that completely plagues beginners. So lock this box into your memory.
Let's see this in action. In part 4, live coding a playlist using arrays in C++. Let's turn this theory into actual working syntax. We are creating a string array called playlist that has space for exactly 3 songs. std's string playlist equals song A, song B, song C. Now, I want you to focus really closely right here. I'm hitting Control-A with turn shot to zoom smoothly right in on these square brackets. See them? Those square brackets represent the literal shelves in our computer's memory. We've essentially just built a shelf, and we've placed song A at index 0, song B at index 1, and song C at index 2. Boom, perfectly contained.
But, what happens when things inevitably go wrong? That brings us to part 5, the out-of-bounds trap and fostering a growth mindset.
A huge part of developing a growth mindset in programming is just accepting that friction and errors are totally normal. Let's look at a classic mistake. Here we're asking the computer to print out a song, stdcout playlist 3, and bam, error. The whole program crashes. Why? Well, think about it. We have a 3-item array. The indexes are 0, 1, and 2. By asking for index 3, we literally just tried to reach for a book on a 4th shelf that physically does not exist in memory. It's totally out of bounds.
I know. Seeing that bright red error text can feel super discouraging, but let's reframe that for a second. Struggle is part of the process. Errors build the problem-solving muscle needed for high-paying roles. Getting an out-of-bounds error isn't a failure, guys. It is a massive learning opportunity. Debugging this exact kind of mistake is precisely the training that prepares you to tackle complex software architecture down the line. Every single error makes you sharper.
So, you now know how to move past single variables, how to build an organized bookshelf in memory, and how to access your data using the zero-index ladder. But I want to leave you with one final, kind of massive thought. Now that you can organize data on a single shelf, how are you going to efficiently search through a library of 1 million books? What happens when your array is just gigantic? Well, that is exactly where data structures and algorithms come into play. And honestly, I cannot wait to explore that with you in the next explainer. Keep coding, keep building those problem-solving muscles, and I'll catch you next time.